exponential functions. A, b to the x. I think that you did a video on what A does to the graph and what B does to the graph on one of your virtual days. Does anyone remember what A and B do to the graph? A changes the y-intercept, remember? Do you remember that or no? So for example, here's my 2 to the x graph, right? Here's my 3 to the x graph. Here's my 4 to the x graph. So I'm just putting them all in. So here's blue is 2 to the x, whatever color comes next. Red is 3 to the x. And this last one is 4 to the x. So what just happened? As the base got bigger, the graph got steeper, right? So the b value, right, is the steepness, right? It's making it steeper each time. But what does a do? So if I change the, let's say this one is 3 times 2 to the x. This one is 5 times 2 to the x. I'm going to keep 2 to the x each time. And we'll call this one, oh shoot. We'll call this last one negative 8 times 2 to the x. So see how now I have the same b value, but I'm changing the a value. I thought you did a virtual on this. So that was the first one, 3 times 2 to the x. This next one was 5 times 2 to the x. And this last one is going to be negative, oh shoot, did I make it negative 8? Oh, negative 8 flipped it over too. I didn't mean to flip it over, but it's changing the y-intercept of the function. So it's going through negative 8, it's going through at 3, and it's going through at 5. So it is the y-intercept of the graph. So you've got your steepness and your y-intercept. So just by having a set of points, you can figure out what's happening and write a function. You don't need to do a regression for these. So first of all, you're going to ask yourself, is this a growth or decay function? So as x increases, what's happening to your y values? They're getting bigger. So this is a growth function, right? Would you agree? Growth versus decay. So what is the a value? Well, what is the y-intercept? What's the b value? So when you go from 6 to 24 or 24 to 96, what are you multiplying by each time? And there's a typo in this table. This should say -1 right here. Sorry about that. You're multiplying by 4 times 4 each time. So your function is just y equals 6 times 4 to the x. So that's it. You find your y-intercept and you figure out what you're multiplying by each time, and you can write the exponential function without needing a calculator. If I go from 0, 4 to 1, 2, are the y values getting bigger or smaller? They're getting smaller. So this is a decay function. I'm going from 4 down to 2. What's my y-intercept? 4, right? 0, 4. What's my steepness? How do I go from 4 to 2? What do I multiply by? It has to be multiplying. 1/2. So your b value is 1/2. So the equation is 4 times 1/2 raised to the x power. So it's a little bit of memorizing the process, realizing that a is the y-intercept and b is your base that you're used to. What about if it's a graph? So if it's a graph, you can still figure out the y-intercept and you can still figure out the different key points. Oh, this one's kind of hard to read. Let's see, this is at 1, 2 and 2, 8, right? Right, so if this is 1, 2 and this is 2, 8, I think I can work backwards to identify the y-intercept. What am I multiplying by to go from 2 to 8? 2 to 8, 4, right? So what does the y-intercept have to be? See how I have to estimate the y-intercept? The y-intercept is actually exactly 1/2, right? Because 1/2 times 4 and then 2 times 4, it has to fit the pattern, exponential pattern. Is this a growth or decay function? Growth. We already said the y-intercept is 1/2 and it's growing at a rate of 4. So y equals 1/2 times 4 to the x. Are you kind of with me on that process? Okay, before we go for a walk, because you're going to have to do 5 through 8 when you come back, I'd like you to try number 4. And if it's hard for you to identify another point on the graph, you can identify this point right here. -2, 4 fits exactly on the graph. So you should be able to write down the equation for number 4. So try it for a minute by yourself. Hmm. Oh, I should have done this point to help you, I guess. -1 is at 2 and -2 is at 4, because you need to be able to see the consecutive y values to see what's happening, right? So if it's decay, it's getting smaller and smaller. So I actually should be going this way, 4 to 2, 2 to 1, and multiplying by 1/2 each time, right? 4 to 2, 2 to 1. So you could either write it as 1/2 to the x or 1, because 1 is the y-intercept, times 1/2 to the x. Either way you're more comfortable with. So now you're going to try 5 through 8 on the back.